Right, okay. Cool. Right, so hi everyone. Sorry for wasting the last 10 minutes of your life, but that's how these things go. I'm here today to give you a talk on revision control. I'll be talking primarily about Git, but the start's more about revision control in general. And as it says, or how to never lose work again, because that's kind of what we're here for. I'm here to make sure you guys don't lose any work in future. So as I said, covering revision control, we're going to be covering what is revision control, and then we're going to be going over Git, and that will be a sort of a practical, I'll do some coding, you do some coding, we'll use Git on the command line, and we'll actually get to use Git, because this isn't going to be one of those boring stuffy lectures where I talk to you for an hour and you'll fall asleep. We're actually going to be interacting and having some fun. So my question is, who here has never lost work? Raise your hands if you haven't lost any work. Everyone in the room hates Milos now. Everyone else here knows what it's like to lose some work. You're like 5 minutes before a deadline, day before a deadline, you're like, damn it! Why didn't I save that file in the right place? And now my cat's gone and eaten my hard disk, and I haven't got it anymore. But this isn't just about losing work because you've lost everything. Say, for example, you're writing something which is very complex and you break it somehow. So it gets into a state where you can't get it back to the previous state it was in. It's 5 minutes before the deadline. You could have handed in 10 minutes ago, but you just wanted to fix that one last thing, and now everything's blown up in your face and you're completely boned. So that's also one of the things we're here today. That counts as losing work in my mind, because although you've still got the same file, it now doesn't work anymore, and that's not good. So what I'm here to say is, not using revision control is always a really bad choice. In my mind, if you're not using revision control, you're doing something wrong. Every time I use revision control, I get to the point where I lose work, or I get into a state, as I said earlier on, where something's broken, and I go, oh no, wait, hang on a second, I'm using revision control, I can go back to 10 minutes ago. I can just get the files off of the remote server, and I look like this. That's what I look like. I'm the happiest man alive, because I went and used revision control. I can get that work back, and I can look back and find things that I deleted about 4 years ago and bring them back to life. Okay? So that's the one rule I'm here to say today. I'm here to say use revision control. If you take anything away from this entire hour that I'm going to be talking for, yes, it's an hour, it's use it. Now, I'm going to do a little bit Tim Berners-Lee here. Can everyone say this with me? Use revision control. For a second, you guys were taking that way too seriously. Okay, so now we're back onto the serious stuff. What is revision control? So revision control, for those lovely people that love acronyms, is more commonly known as source control management. Now, it comes in lots of different flavors, lots of different shapes and sizes, but primarily they're all there to make sure you can keep track of files, creation, deletion, changes, that sort of thing. So as a file progresses through time, they'll be keeping track of those changes. In addition, a lot of them provide you with backup functionality, so to back up to somewhere else that's not the machine you're working on, which is, as you all know, backups are key. Biscuits sat down the front here when you all started your degree would be shouting at you, backups for the love of God, because backups are amazing and they save your ass so many times. I shouldn't be using that sort of language, sorry. So as I said, they come in all shapes and flavours, but the two main types, you've got centralised SCMs. Now, a centralised SCM is very typically your server and your client. Now, your server will be where you store what's called the repository, so all the changes to the files, all the history, the logs, who did what when, essentially. And on your client machine, you'll have the most recent version of the code checked out. So you'll just have basically a snapshot in time on a local machine. You push changes to the server, you get changes from the server. You don't store anything on a local machine, which is where decentralized SCMs come in. So decentralized SCM is what it sounds like. It's not in one central location. You don't have a central server that has your crown jewels in it. It's not a bank vault. Everyone has a copy of everything. Now that sounds really inefficient, but it actually works really, really well. So a good example of decentralized SCM is Git, which we're going to be talking about today. So anyone can be the server, anyone has everything, and it allows lovely things like offline usage. So say, for example, you're trying to work on the way to work on the morning, you don't have internet connection on the train because 3 are rubbish, and you're doing a little bit of work, you can still carry on committing and things like that because you've got everything on your local machine. You don't rely on that remote server at all. Now, a really good example for me where this came to light was recently is we were doing our 4th year project at UP. And a day before we were due to hand in this massive document we've been constructing, our pride and glory, our little baby we've been sat on, my server at home, the internet connection goes down. Obviously, I call BT, and they're like, we can't help you. So I take the Git repository, I don't even have to go home, actually. I don't take the Git repository. There's 4 of us working on it. I wing round each one of us, and because we've all got a complete copy of the repository, I find out who's got the most recent version. I take their copy, stick it on another server in ECS, and we're back up and running again in 10 minutes. I didn't even have to go home to get the repository off of my server. With a centralized SCM, if my server were to blow up, if I didn't have a backup of that, I've lost all of my revision control. I've lost all of my history. So if you use an SCM, you have to back up your server every 25 minutes. With a decentralized SCM, one of you will always have a copy of something somewhere. So even if an apocalypse strikes 5 of you and the 6th person's okay, you've still got a copy of your dissertation to hand in. A bit less important because it's an apocalypse, but never mind. All right, so we're talking about Git today, primarily. There are a lot of other decentralized SCMs out there, but I'm a Git man. Many of you might be Git men, and I thought probably be appropriate to talk to you about Git because it's one of the most popular revision control systems out there. Before any of you start throwing figures at me, I'm just making that claim. So it traditionally, as I said, decentralized SCMs, you've got your local and you've got your remote. Now the remote for us today is going to be GitHub. That's what we're going to be using. And I'm going to be talking about all these big red arrows we've got going to and from all the different components. But the important thing about this is you've got your local and your remote, which is one of the most lovely things about this, is that you don't even need a remote, you can do it locally. Okay, so as I said, I'm going to be talking about Git, but I'm not going to be talking about the really heavy internals of Git. I'm not going to be going into a lot of detail. I'm just going to be telling you how to use it. If you really want to know about how Git stores all of its objects and how Git stores these changes, by all means go Google it, but I'm not going to be telling you about that today because that will be a year of your life. You know, you might want back, you might not want back, it depends. But I'm not going to be talking about it today, but Google is amazing. There's a lot of really good documentation online for Git, a lot of really good documentation. So if you go away today confused about anything I've said, the manuals online on GitHub will probably clear it up for you, or you can ask me afterwards. In addition, if anyone has any questions while I'm waffling on, just put your hand up. This isn't a strict lecture, as I said, it's kind of a more informal chat. So, with Git, there are different things you can use. On the very low end of things, you've got Git itself. So this is the command line tools that actually do all the heavy work. You've got Git SVN, which is kind of an interface between SVN. It's a Git front end, isn't it, to an SVN repository?
It acts like a remote.
It acts like a remote, yeah.
It's complicated.
Yeah, it's quite complicated. I just put it up there because someone asked me to. And then you've got applications that you can use in front of Git. Now Git's very command liney, you can use it very command liney, but I myself love using an application to work on it because I'm not always wanting to type in late at night. I just might want to click the commit button, and I use what's in the middle there, GitHub for Mac. Now it's basically GitHub have produced an application which does all of the sort of command liney stuff for you in a very nice interface. Another one's GitX, that's cross-platform, and you've got Dropbox. Now Dropbox is the odd one out there because it's not Git, but it's something I wanted to talk about because, as I said, use it is the thing I want you to take away from today's talk. Now I didn't necessarily mean use Git, I meant use revision control. Use something that will help you save your files and back them up. Now Dropbox is amazing for that. Dropbox is literally an install and put your files in that folder. I don't care about them, you can do whatever you want with it, just stick them in that folder and Dropbox will save them remotely for you. And the amazing thing about Dropbox recently is they changed it so it has revision history. So I'm talking here about revision control. Dropbox is now a form of revision control. It's a very simple revision control. You don't even have to do all of the complex committing stuff and things like that. You literally just put the files in a folder and they're safe. So if you take anything away from today, just go and sign up for Dropbox and use it, because that will make me happy and it will make you happy when you don't lose anything. More about sort of the online side of things. So I've been talking about the remote parts of Git, so you have the remotes. There are many services online for providing these sort of remote repositories. Bitbucket's one of them, that's an Atlassian spin-off. They do a lot of free repositories for you, they're free private repositories. But they charge for kind of more teeny things. That's not even a verb, but teeny things. Then there's GitHub. I keep saying GitHub today, that's what we're going to be using, so you'll all be familiar with it by the end of the day. They do open repositories. So if you want to keep it private and you want your code to keep your code to yourself, you're going to have to pay GitHub some money, which is where Bitbucket's slightly different because that's private. So you can keep your code yourself on Bitbucket. God knows how they make money, but GitHub, it's all open. And then you've got Google Code on the end there. That's for people that like using Mercurial and SVN to other types of revision control. So this page is essentially just to tell you there's a lot of stuff out there for Git and revision control. You don't have to sit there looking at your terminal all the time, which is why revision control is a wonderful thing. There are so many different ways of using it and so many intuitive ways of using it, and it doesn't all have to be boring. So this is where it gets more interesting. Everyone's got a laptop. Who still doesn't have a GitHub account? Raise your hands. Awesome. Who doesn't have public-private keys set up on their machine? Awesome. Chris, I hate you. So what we're going to do today is we're going to go through all the Git commands that... Well, I'll just get on with it. That'll be easier. So this is my desktop. It's fairly boring. So if we head over to GitHub... Right, you guys are doing this as well. Everyone head over to GitHub. I'm going to have to sign in. To be honest, if anyone didn't have an account, by the time I sign in, you'll probably have one. There we go. Right, so this is what happens when I open up GitHub. Now, GitHub's amazing for two things. One, it provides me with a remote storage for all of my code. And two, it gives me quite a lot of social aspects. Tom Hennigan, you've changed your code recently, apparently. So what I can do is I can follow other projects and things like that on GitHub. It's a bit like Facebook, but for code. A bit more nerdy than Facebook. So I can follow other people and I can see what changes they make to their repository. So that's really good. For example, if I'm using their code in my code, I want to know if they've gone and updated their code because I was using it in my code and it was pretty bad when I started using it, and I'd like to know if they've improved it. So I can follow users and it comes up on the side there when they've done something, and I can go, oh, I'll see if I'll update my one. But that's kind of a secondary feature. The primary feature is what we're going to cover today, and that's remote hosting. So if we go up here to this little box in the corner and click Create a New Repo, we're going to create a repository for what we're going to do today. I'm going to call it Learn Git. You can call yours whatever you want. Description. Dev. It's always nice to give your repository a decent description so when someone comes to it, they're not completely befuddled by what's inside of it. Okay, don't initialize your repository with README because we're going to be doing that manually today just for learning purposes. So if I go ahead and create my repository, GitHub is really, really, really nice, and they've just given me a list of instructions to run to create a Git repository and get started. So you could just go and copy and paste that into a terminal, but we're not going to today. We're going to dissect each part of that, and we're going to look at what each part does, so then you get more of an understanding about how Git works as a whole. So, right, what's the first one on there? Git init. So, Git init is kind of, it's the way we create our repositories, or as I've referred to it, where the baby repositories come from. So when you want to when you want to take a folder and you want to revision control it, you literally just type Git init, and that will create a repository in that folder for you. Now, that's the simplest way I know of creating a repository. If anyone knows an easier way in another language, put your hand up now, because that's pretty damn simple. But before that, we've got to take care of a bit of housekeeping. Now, we've got to tell Git who we are, because it's very important when you're working on a project with other people. It's very important that they know that you've made a change. Now, it might be bad for you if you're a really bad coder. You might not want people knowing who you are, but first of all, we've got to set our name and our email address so that any commits that we make, we'll be talking about commits later on, any changes essentially, any changes that we make will have our email address and our name on it. Because if, say for example, I break an entire build, or I go around deleting files willy-nilly in some drunken rage, someone's going to want to email me and tell me I'm an idiot. And that's quite important nowadays. So let's head back to the command line and run these ones. So the first one we've got to do is we've got to create a folder. So anyone not familiar with Unix command line tools? Make dir creates a directory. And you can see it's popped up over here. Nothing in at the moment. Okay, so as I can say, completely empty. So let's run that fable command, git init. Okay. So Git's gone and told us you've created an empty repository inside that folder. If we have a look, this is basically the bread and butter of Git. This is like in the bonnet of your car. It's kind of, don't touch it unless you really know what's going on. It's much easier and safer for your entire life if you just don't fiddle around with anything in there, unless, of course, you've got a specific purpose to be in that folder. So we're going to leave that alone today because I don't want anything bad happening. Right, so on to our next function, Git status. Now, you might have noticed that's not on the list of files that, the list of commands that GitHub told us to run, but Git status is one of those key ones that I thought you'd all need to know pretty early on. So essentially, whenever you do anything in Git, it knows what's going on, and the easiest way of us knowing what it knows is going on is to type Git status in. That will basically show us what files it's keeping an eye on, what files it's not keeping an eye on, what state what files are in. It's also really useful in the fact that it gives you a little bit of advice on what to do if something is in a specific state. Up here you can see it's telling me I have an untracked file called readme, and it's telling me to use a function on it to include it in, I fell off the end of the page, but include it in the revision control. So let's run Git status. First of all though, we're going to want to create a file because it's pointless to revision controlling an empty folder. So let's create a readme. So touch readme. Anyone not know what touch does? It just literally just creates a file. So now we have an empty file called readme. So for my project. Okay. So there's a readme. So now we've got a readme in the folder. So if we run git status, exactly what you just saw on the board 5 seconds ago, Git's telling us, well, I've got an untracked file. I've never seen this file before. What do you want to do with it? Because Git doesn't like having things, it likes to know what's going on. And if it's telling you, if you want me to keep an eye on this, you're going to have to do something with it. And that's what we're going to talk about next. Is our next function. Sorry, I have to keep switching through, but this is the easiest way I thought of doing it. Git add is our next one. So if you like changes to a file, we run git add to basically tell Git, all right, I want you to pay attention to this because this is something I think is important. I really like my README file and I'd like to revision control it. So what we do is we run git add to add the changes to this file to what's called our staging area. I'll talk about staging area in a second. I might actually. No. So what git add will do is basically add our file to the revision control. But it's not quite fully added yet. We'll talk about it later on. It's just kind of keeping an eye on it for the moment. So git add readme. So if we run git status again, as I said, git status is your bread and butter. If you don't know what's going on, if you went away, had a cup of tea and you come back, you're not sure what you were doing 5 minutes ago, git status is where it's at. It will tell you exactly what's happening in your repository at that time. So as it's saying, changes to be committed. So they've not been committed yet. They're to be committed. So you're kind of in this little sort of limbo state at the moment. But what it's saying is that it's keeping an eye on README for you. Now, by limbo, what do I mean by limbo? Well, as I said earlier, there's this thing called the staging area. Now, as that diagram I brought up earlier on, it had kind of the 3 major components of the local part of Git. Now, those are your working directory, your staging area, and your repository. Now, the repository, as I said earlier, is somewhere which stores all of your changes, all your revision control, everything that's happened up until now. And your working directory is the files you're looking at. So when you open up a folder and you type ls, or you open it up in Explorer or something and you're looking at some files, that's your working directory, what's happening right now in that folder. Now the staging area is kind of a middle ground. As I said, it's kind of a loading dock before your code goes off to commit still. So when you git add, Git takes your changes to the file, to anything, and adds it into the staging area, kind of temporarily storing that state of that file ready to be commit into your repository. And that's where the git commit command comes in. We'll talk about it in a second. But it's key to get through this stage, through the idea that there is this middle area, the staging area, which is kind of, it's not in the repository yet, it's not stored, Git hasn't taken a photo of it, it's just waiting there to be done, for something to be done with it. Alright? So git commit. we saw it earlier on, that's how we get from our staging area to our repository. The simplest way I can think of explaining git commit is you're essentially taking a photo of your code at that time, and Git's going away and putting it in its photo album. There's a lovely holiday to Malta there. So you're taking a photo of it and you're storing a snapshot in time of your code at that point. So whenever you want to store a change or record a change, you'll do a commit, and these commits, these photos, can be sent off to your remote repository, and they can be restored to at a later time. So when we've done the git add into our staging area, we're kind of telling Git, all right, okay, this is important. And then when we commit it, we're going, well, this is really important. I want you to remember this for the rest of time. And then in 3 weeks' time, you go, damn it, I really want that file at that point in time. And because you committed it, because you've got this snapshot, you can have a check through your photo album and went, that one. That is the important one for me. I want to bring that back to life and look at what's there. So that's what commit does. There's a little bit more about commit. Commit's kind of like the biggest part of revision control, really. So for every commit you do, you have to leave a commit message. Now this is key for working in a team. So I commit, and I have to go, all right, so I was working on this file, I was fixing a bug. And it's important to note, I don't care if you're going to lunch in your commit messages. I really don't care whether or not you just ate a sandwich. What I do care about is what is the purpose of the commit? What you were doing at the time that caused you to want to make this commit. So features you've implemented, bugs you fixed, the purpose, really just the purpose. How often do you commit? Well, personally, I commit like every sort of quarter hour to half an hour when I've got something solid and bulky that I like, that's stable, that I want Git to remember. Because the more often you commit stable code, the easier it is for you to get back to a previous version. So you can commit however often you want. But if you only commit once a day, if you had something in the middle of that day that you really want back, you're not going to get it back, because at no point did you tell Git, actually, please remember that, because I'm probably not going to be in the right state of mind tomorrow and I won't remember what that is. So if you were writing the DaVinci code and you got halfway through the day and you turned it into rubbish code, you're not getting the DaVinci code back, because at no point did you tell Git to remember it. Alright, so let's commit our code. Ash is holding his hands in his head. Is it that bad? Right, so git status again. So as it says, one change to be committed. And we all know what committing is now. So let's do git commit. So when you type git commit with no arguments, it will open up your default editor. For me, that's Vim, and anyone that turned up to Pat's talk last week will know exactly what Vim is. To anyone else, it's basically a command line text editor, but it's how we're going to be entering our commit message today. But I'm going to exit out of that quickly, because what's the point of having a repository with just a README in it? Here's a hello world example I created earlier on. Put any file you like in your in the folder right now. Drag and drop a folder, some pictures from Holiday, or preferably not pictures, something text-based would be better. So I'm going to drag and drop this hello world example into my repository. I waffle for a bit more, so you can write one in your spare time if you like. So now if we do git status, we've got one track file, one untracked file. So git add hello world app. Git status again. 2 files to be committed. So git commit. And what's the purpose of my commit? Why am I committing this? Well, I'm initializing my repository. Anyone know how to spell initializing? That is completely wrong, but never mind. Repository and adding base code. So I'm not the greatest one at coming up with commit messages, but I'm trying to basically tell all the other developers that might be in my project what I was doing. Now with git commit messages, you can leave what's called a short message, kind of like a tagline for your commit. Like you short, snappy, this is awesome, kind of why that commit's good. And then you can waffle on for a bit more down the bottom with some extra messages, but it's such a small commitment at the moment, there's not really much point of that. So if I save and exit out, :WQ for anyone that wants a little bit of revision on Vim. So I just committed my first commit. So Git's really helpful in the fact that it will come up and tell you exactly what you're doing all the time, really verbosely. So it's telling me I've got 2 files that I changed and 2 files I've created. 6 insertions, so that's lines that I've inserted. So we had 5 in the Java file, 1 in the README. And it's telling me the message that I just made for that commit. So even after I've made the commit, I can still see exactly what just happened. And I can use another command that's quite useful called git log. Now git log will tell me the history of what's happened. So now what I've done is I've taken a snapshot of my code at that time. I can make any changes I want now in the working directory or the staging area. That won't affect this. This is a picture I've taken of my code. And that picture can be changed, but we'll not talk about that for the moment. That's kind of like complicated Git. But that picture is kind of static for me as far as I'm going to be using the repository, and I can refer to it at any time. So you're all wondering right now, okay, so where the hell does GitHub come into this? Where do my remotes come into this? Well, at the moment, we're perfectly fine. We've been using our repository for local revision control, and that's awesome. So you don't even have to add a remote to your Git repository. You can just keep programming away on your own machine by yourself, making commits here, there, doing whatever you like, working by yourself. And that is perfectly fine. Git allows you to do that. And that gives you that revision history and the change history that is really important with Git. But it doesn't give you the extra added super benefit of having offline backups or being able to work in a team. You can work in a team, you can email them the entire repository if you want, but that's kind of a stupid idea. So we have the idea of remotes. Now, a remote is essentially somewhere else that our repository is stored. Somewhere that's not our local machine. And we have to tell Git where these things are, because Git's not a mind reader. We need to say to Git, okay, this is where we're going to be storing this elsewhere. And we also need to give this elsewhere a name. It's like your house has a number on the front of it. We give our remotes a name. Now here, what we're doing is git remote add origin, and then GitHub. GitHub URLs are normally in that sort of format. You guys aren't going to be adding my GitHub repository to remote, at least I hope you're not. You're going to be adding the one that you got on when you originally opened your repository. GitHub will have told you what to add as a remote, so copy and paste that instead of copy and pasting mine, because you'll just get a permission refused if you try and use mine. But git remote add origin. Now origin is the name that we're going to give to this remote, and origin is kind of naming standard, isn't it? You kind of pick origin as the default, I think.
It doesn't have to be.
Well, it doesn't have to be called origin, but that's
the one you get if you clone.
Yeah. So we're going to call ours origin because it's where everything's going to originate from. And then obviously having a remote isn't much use if we're not going to go and send something to it. So our next function is called git push, or sharing is caring is a common phrase. So what we're going to do is we're going to take the changes that we've got on our local machine and we're going to push them to the remote that we've just specified. So we're going to essentially synchronize. It's referred to as synchronize. We're going to synchronize our remote repository with our local repository. But as our remote repository doesn't even exist yet, all we're going to do is just take ours and give it to them. And how this is done is you specify what remote you want to push and what branch you want to push. We'll talk about branching for the moment, but just take it as read is that master is our kind of our key branch here. It's the trunk of our repository essentially. So what we're going to do is we're going to go away, we're going to add our remote in, and we're going to push our code to GitHub. Right, if I can, I'm going to copy and paste from Git if you guys don't mind. Right, so got my repository. If we type something like git remote, Git by default will say what remotes you have, and we don't have any at the moment because we haven't told Git anything. So git remote add origin github at github.com, my username /learngit.git. So that's the location of my repository on GitHub servers. So if we type git remote again, there we go. We've got one remote called origin. So this is where I'm going to be sending everything. And our next one was git push dash, if my memory is good, origin master. So what I'm going to be about to tell Git is I want you to push changes that I've made differences between mine and the remote, and as the remote doesn't exist, that's everything. To origin, which is my remote from my master branch. I hope it was a -u flag, otherwise I'm going to look like an idiot. Oh, we're all good. Okay, so what Git has gone and done is it's gone and taken all my changes and shoved them upstream to our remote. So if we now go back to GitHub and refresh that page, there we go. There's my code on GitHub. I've done my first commit. They've got my Java file, my README. At this point, I can start sending you guys links going, hey, look at my code on GitHub. You know, do you want to download it and work with me on it, or that sort of thing? But it's now all up there. GitHub is also really amazing because of this. It will take the README that's in a folder and it will display it nice at the bottom of you. So if you want to provide sort of user instructions for some code you're writing, you can stick it in a README and GitHub will format it nicely at the bottom of the page for you. So people go to a repository and see, oh, there's a user manual straight down the bottom there. Right, so we've got our code to GitHub, but what happens if we're working with other people? What happens if they've made a change? We need to get the code from GitHub and pull it to our local machine. And this is where git pull or git fetch and merge come in. So obviously we've shared and cared, we've given them our code, but now we want something back. So how do we synchronize our local repository with GitHub? Well, we use these commands. You can either do a git fetch and merge, it's kind of a two-part thing. So a git fetch will take the changes from the remote repository and synchronize your local repository with it. So you remember the three kind of tombstones of Git that we had earlier on. There was the working directory, staging area, and local repository. It will fetch the changes and synchronize them to your local repository. So you won't see any of these changes. We haven't put them in the working directory. Your working directory is still everything you want it to be. It hasn't changed. What git merge will then do is take the changes that you just pulled in and merge them into your current context, as they refer to it, so into your working directory. So you will then see changes that other people have made when you look at your files in your file browser. So that's two steps. So we're going from remote, hopping into our local repository, and then we're going from our local repository into our working directory. Or, if you're lazy like me, I have never done a fetch and merge. I always use a pull, because, why write two commands when I can write one? I'm just lazy like that. So just git pull will take the changes from the remote repository, synchronize them to your local repository, and merge them into your working directory, all in one fell swoop. Right, so for those of you that fell asleep, too long didn't read, this is what we've covered so far. As I said, these are the three bars of our local repository, and then we've got our remote. So think of remote there as GitHub, local is your machine. So we've covered git add, so that's how we tell Git, alright, okay, something's about to go down, we really want you to pay attention to this. Then we covered git commit, so those changes I just told you about, well, I really, 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 really want you to remember them, because they're going to be important somewhere down the line. So keep hold of them for me, because I'm forgetful, you're not. You remember them for me. So git commit will push it, snapshot it into your local repo, sealed in time, essentially. Then we talked about git push, so no good having my changes on my local machine if I'm going to take my laptop out and it's going to get stolen by someone nefarious. So I git push my changes and synchronize my repository with the remote one. And then we talked about git fetch and git merge, which pulls changes back from the remote repository to your local repository, or git pull, which does both of those at the same time. We haven't talked about git checkout yet, so I'm going to quickly cover git checkout. So, as I was talking earlier on, we all make changes to our code, and we all mess up stuff. So, say for example, as this project, I'm working on my project, and 10 minutes before hand in, I'm like, right, okay, one extra feature. I've got this one extra feature to get these 10 extra marks, I'm going to try and implement this. And I completely balk the entire thing. Doesn't run, doesn't compile, I don't know what's gone wrong. That light just gone, I don't know what's gone wrong. I really need to, get back to the version. But I haven't made any commits, so I'm fine. It's just my working directory which is, changed. The most recent version that I committed in my local repo, big blue blob, my green blob's messed up, but my blue blob's fine. So I do a git checkout. Now that takes what's in my blue blob, my local repo, and it reverts, it checks out what's in there, overwrites my working directory, and takes me back to a version, which is nice, which I can then send to my lecturer, who isn't going to hate me for the rest of his life. Am I right so far, Nick? Nick's my Git expert down the front here. He pretty much knows Git inside out. He'd probably sleep with Git, in all honesty.
I don't use checkout for it, I use reset, but
you use reset.
It should work.
Does pretty much the same.
Yeah,
okay.
You probably have to specify which commit you want to check out.
Okay. So the other nice thing about Git checkout is you can use it to check out commits as well. So we're talking about these photos that we're taking. You've got your photo album from Git. Everyone realises this is just an analogy. It doesn't actually take photos. So you've got all your lovely photos, and you can pick one of them, and you can do Git checkout and then insert photo here, and that will take you all the way back to that point in time, so you can see how everything looked back in, I don't know, the 1990s or something, whenever you commit. Right, so the last thing I'm going to talk about today, because I've gone on long enough and I need a drink, not that kind, is Git branching. Okay, so Git branching is one of the coolest features of Git. So at the moment, we've been working by ourselves, we've been pushing and pulling from a remote repository. But what Git allows you to do is branch off what you're working on to implement a feature. Is commonly what you'll use it for. So you'll branch off, do some little changes, and then you can branch back in again if you want to, without affecting what's on the other branches. So it's like the branches of a tree. You wander along one, but you're not affecting the others. And then you can come back and pull all the changes back in again. And these branches are so simple to create. There's no overhead to them. So you can just branch whenever you fancy. You can branch all the time. You can have a million branches if you really want to. It might get a bit confusing for you, but Git makes it really simple just to branch and then pull them back in. Right, I'm going to show you pretty much everything I just talked about in the last 5 minutes all in one go. So I hope everyone's following and has got fast fingers. So, right. In my repository, I've got my Hello World Java application. Please don't open Xcode. Oh, it's opening Xcode. So we'll wait for Xcode to decide what it wants to do. Oh, great. Everything else I was looking at for the entire day. Cool. So now we've got our Hello World application there, right? But I'm not a very good programmer, and I really don't like semicolons. So what I'm going to do is I'm going to get rid of this semicolon here because I don't understand Java syntax, and I'm a bit dippy. So I've gone and deleted the semicolon because I think it looks slightly prettier without that, don't you? It looks slightly nicer. So another thing that I haven't spoken about is the fabled git diff. Now what git diff will do is it will tell you the difference between what's in your repository and what's in your working directory. So here, I've made the change, I've got rid of the comment, I've got rid of the semicolon, and I've said, hey git diff, what have I done? And it said, okay, well you've taken one line out, you got rid of that line, and you put another line in. So it's essentially a changed line. So if you, say for example your mum calls, and you've been working on a file, and you come back and you're like, damn it, I now can't remember, I didn't want to hear about like the dogs went on a walk or something, and now I can't remember what I was doing in my code. Git diff quickly tells you what you were up to, it tells you what you changed from your last commit, and if you're committing regularly, it hopefully shouldn't be too much of a diff. So we've got a git diff here. I've done something monumentally stupid, but I don't realise this. So what I'm going to do is I'm going to add my Java file. Okay, so git status should tell me it's ready to be committed. Okay, and I'm really, really stupid, so what I'm going to do is I'm going to commit it, but I'm going to give it a useful message. Why not? I'm not that stupid. Added. Actually, for anyone that knows me, spelling is a real task. Added, there we go. Okay, so I've just added another commit of some broken code. You're kind of taking it for read that that's broken. So let's try and compile it. There we go. So it's broken. You got a hand up, Rob. Go for it.
Yeah. Can you? I'm assuming you can. Can you put a message on the command line?
You can do, yes. You can do single line commits. I'll show you that in a second. There's one more commit I'm going to be doing, and I'll show you it. And when you all got the guide up originally from GitHub, it said git commit -m insert message here. That's a one-liner that allows you to put your commit message in then and there. Saves you having to go into a text editor, but I always use a text editor so I can input a verbose message that tells everyone exactly what I'm doing. Because I want to leave a verbose message. Another thing I didn't mention about Git commit messages earlier on, is that you've got to remember other people are going to be looking at these commit messages and thinking, what the hell does that do? You don't want them to have to look at the code that you've changed, because that's just going to take them ages if you've got a massive project. But they want to be able to quickly go through your commit messages and go, right, okay, I'm looking for feature 15, okay, there you go. That's the feature I'm looking for, that's the change they made, that's the feature they implemented, I'll have a look at that one. So your commit message has to be kind of verbose to that extent. I forgot to mention that earlier on, sorry about that. But anyway, here we go. I've got a broken file right now, and I've committed it to my repository, and I've even pushed it to GitHub. So, really simple git push. So after we do our first push, what we did is the -u. Everyone remember that? That set my default branch and remote, if I'm right.
It sets the branch to track.
Yeah.
So kind of.
Kind of.
It means that
It allows for commandless pushing, does it not?
It means that every time you run push, it will use that branch, that remote branch as default for what it's merging with.
So we'll basically set the defaults in that original one. So I can now just do a git push, and I push my changes to GitHub. And if I'm now working with anyone else, they're going to be really annoyed because I've gone and broken the build, and I wasn't too popular beforehand, and now I'm really not popular. So what I'm going to want to do is I'm going to quickly want to change the code. But as I said earlier on about git branching, you can git branch for features. So if I do git branch, or if I do branch, if I can spell branch, so we've got one branch at the moment. That's that master branch I was talking about earlier on. So we're on one branch. So if I type in git branch mental, okay, so git branch. So now we've got two branches. I've just created a branch. As I said, really no overhead for creating a branch. Simple as that. And we're talking about the git checkout command earlier on. There we go. So now I've switched to branch experimental. So what I'm going to do is I'm going to make some changes on my experimental branch. And this won't affect my master branch at all, because I've now split off, I've diverged. The train tracks have split, and I'm going to be working on one, but I'm not going to be anywhere near the other one. So let's make a change to my Java file again. So I'll close that, open it again. So as we can see, no semicolon. Let's put the semicolon back on there and put, I'm really sorry. Because you want to be apologetic to your boss. That's not proper commenting, so let's just print hello world. Point hello world. Anyone want a point? Okay, so now we've got print hello world there. So git diff, tell us what we've changed. There we go. Added a semicolon in. We want to commit it. So first of all, git add hello world app. So git status will tell us we've got a modified file and it's ready to be committed. They're modified now because Git already knew about the file and we've now made changes to it. So it's modified. It's not new, it's modified. So then we do git commit, and git, we'll do that single line just for Rob there. Fixed error. We fixed the compilation error. Okay, and as you can see, git being verbose as always, right?
Where you just done git add, where you switch the branch, does it not copy over the list of watched files?
Where you already had hello world apps.java on the master branch, you added it to the experimental branch. Does it, when you made a new branch, does it not automatically copy?
No, I added my changes. So I didn't do git status beforehand, sorry. So when I split off, it keeps all of the context.
On changes, not what commit does?
No, I was adding the changes that I made to my staging area.
So it's like different from SVN where you only have to add the first time you add the file.
Yes. So Git is different from SVN. I didn't mention this. I really should have done. Git is different from SVN in the fact that every time you make a change in SVN in your working directory and you do a commit, SVN will bundle everything that's in your working directory up. Working directory, bear in mind, there's no staging area, and it will send it off to the remote server. Okay? Whereas with Git, if you do a Git commit and you haven't told it that you want to stage any of these files for changes, it will just go, well, there's nothing to commit. What are you talking about? So you have to specifically tell Git you want to commit these files by putting the change into the staging area. Whereas with SVN, it's kind of a all-seeing, all-dancing commit. Everything goes all in one go. Whereas with Git, you have much finer control over it. You have much finer control over what gets committed. So, say for example, I'm working on a project and there's a bug in it, and I've got 100 files, and I know, right, one of these files has the bug in it, and I don't know which one it is, but I'm going to do a bit of finding around all my files, make some changes here, make some changes there. So say for example, I change like 20 files, and I finally find that one golden file that has the error in it, and I fix it, and everything's wonderful. With SVN, I would have to revert all the other files back before I could commit it, because as I said, it bundles everything up and sends off in one go. Whereas with Git, I can say, right, I found this one file, git add that one file, git commit, it will commit that one file off, because that was the golden file I was talking about, and that's the one thing I wanted to pay attention to. So I've taken the one change that I want and I've sent it off. I am making sense here, aren't I, Nick?
Yes.
Good.
And then would you run git checkout together?
Exactly. I would then git checkout, and it would check out what's in my local repo. It would replace all those changes that I had on all those files and reset everything back to normal again. So if I've just gone around putting print lines everywhere, it gets rid of all of them. Or git reset. Git reset's the proper way of doing it.
Yeah. You can also kind of replicate the SVN behavior by using the A flag on commit. So if you do git commit -a, it will commit all files that are changed and being tracked.
But then, yes. We tend not to use it when we're doing Git though, because it's very nice to have that sort of intricate control. And you might be committing stuff you don't want to commit.
Okay.
So say for example, I've changed all those 50 files, and I've forgotten to check out one of them or reset it back to what it is, and I do git commit -a, it just goes right all of that to the server, or all of that into the repository, and then if I committed one of those files I didn't want, I'm going to be a bit, I'm going to have to revert that back again, because I've just committed something I really didn't want to add. So that having that staging area is really nice, because you can type git status as many times as you like, and it will tell you exactly what's going on at any point in time, and it will tell you exactly what you're about to commit. And that's another thing about not using the -m flag on git commit, because when I typed in git commit, you saw it came up with my editor, and it said files that are being changed down the bottom there. So I could, while I'm typing my message, I could be looking at the bottom of the page and going, "Oh, I don't want to commit that file. Exit." That's a last kind of ditch attempt to save yourself from committing something that really shouldn't be in the repository. Say for example, you store your music in the same place you store your code. You don't want to commit that to the repository. So yes, what's happened here is I split off all of the Java files went off as well, so it kept tracking those, and I just made a change to my Hello World app file. I added that change and I committed it. So what's differing now? So if we got Hello World Java, and if I open up the file, as you can see, it's got it should hopefully have my semicolon and my comment on the end of it. But if I do git checkout master, so that's taking me back to my other branch. Switch to branch master. So if I now open up my Java file again, my comment's not there anymore, because you remember I split off from when my code was borked. Like my code was broken, I split off and I fixed it. But I fixed it on a branch. So on my other branch, that fix doesn't exist yet, because that remains untouched. I've merged off, I've made some changes, I'm trying to fix something, I fixed it, but on my main branch it still remains untouched, which is good for developing features. Because if I want to go off and I want to make this crazy new feature, I can break off and make this crazy new feature, and my central branch doesn't get changed. So I still have a copy of my code in perfect working order that I can quickly switch to, do some work on that if I really want to. But I've branched off to do all these changes that I want to do in one kind of in one block. So, and you can name your branches anything you want. So you can say branch, bug 5, branch feature 3, branch feature 4. So I can develop features on different branches. It's commonly what it's used for, really, I think, isn't it? Yeah. So branching, you could just put a feature on each branch if you want. Yeah. A good example of this is within DevEX itself, we have our website, and our website is Git controlled. And we actually use Git throughout the whole of DevEX, which is one of the reasons we thought we'd put a talk on for it. And we have a master branch, which is where, so we change our website and we commit to our master branch. And we have a production branch. Now, production branch is live quality. So what you see on our web page is what's in the production branch, word for word, line for line. So we commit to the master branch, and only when we are completely sure that we've got something on the master branch which we think can be put on the live web page, do we then do what I'm about to do and do a git merge from one to the other. We take those changes and we put it on our production branch, which is then displayed on the website. So that's a really good example of why branching is awesome, because you can have one where you're just making dirty commits, and you have this other pristine, holy branch that you only ever push code to when you're really sure it's exactly what you want. So anyway, as you can see, I just switched to the master branch, and there's no code. So if I switch back, just to show you one more time, check out my experimental branch, and there's my fix. Right, so it's not much use for everyone if it's on the experimental branch, and that's only on my local machine. Bear in mind, we're still only working on my local machine. There's no experimental branch on GitHub or anything like that. So what I can do is, if I check out my master branch, I can then do a git merge, because my boss hates me and I really want him to like me again, so I want to merge in my changes to the master branch to bring in all the differences that I made on that branch back in. So I'm merging that branch back in again. So all I say is git merge experimental, and as you can see, that's taken the changes to hello world app.java and it's merged them back in again. So even though I made those changes on a different branch, they're now on the master branch. So if I do git branch, there's master. So I'm on master at the moment. And there we go, there's my fixed code. It's merged my changes that I made somewhere else back onto master. And what I can even do is I can do... So this is how you... As I said, branching is really easy, and deleting a branch is really easy as well. So now I don't have my experimental branch anymore. I've only got my master branch. But I made all the changes I needed to make on it, and I merged them back in again. So the experimental branch wasn't useful for me anymore. So I fixed my bug. My code is still intact, hopefully. And what I can do is I can then push to my remote repository. There we go. And once again, using that git log command, you can see the two original commits I made without branching. So I didn't even introduce branching to you guys at that point. And then I branched off, fixed my compilation error, and then I merged that back in again. And that's all on the master branch, as if nothing happened, as if I only ever did it on the master branch. So I branched off, fixed something, and then when I was really sure I really wanted it, I brought it back again. And then, because I pushed, it should now be back in GitHub. Pushing other branches. Yes, you can push other branches as well, but to be honest, I've been going on for 50 minutes now. You can push branches to GitHub, so that other people can work on other branches. So, as I said with DevEX, we've got master and production. Those are both branches that exist both on my remote and on my local, so I can check both of them out, push both of them, and they can switch between the two on either one. It's very easy to push a branch, but it's something I'll let you Google, because there are about 1,000,001 things I haven't covered. I'm basically just covering the core of Git right now. Okay, so far we covered how to create a repository, how to add to that repository, so how to make sure, adding those changes in that we really want to add, and making sure that those are sort of the key ones, the key code changes that we made. We then worked out how we commit and take a snapshot. We then push the code to remote. We pulled the code. I told you how to pull the code back from remote. I can show you that now, actually, because another really cool thing GitHub allows you to do, so Lena taught me at the front here, she's got a smile on her face, is you can actually change your README file on GitHub. Or any file. Any file, actually. I didn't know you could do all files. So, README should be one word and capital letters. So, fixed capitalize. Why did I give myself a hard word to spell? Thank God for autocorrect. No spelling suggestions.
We're not American, Phil.
Sorry, I went to America for 2 weeks and it's rubbed off on me. In README. Okay, commit changes. And that's all done through a GUI. So today we've been working entirely on the command line. But I don't work entirely on the command line. I've just been showing you how to do it. This is like learning how to drive a manual car. If you learn to drive a manual car, you can learn to drive an automatic car in this country. Or you've already learned to drive an automatic car. You're allowed to drive both. But if you only learn to drive an automatic car, you can't drive a manual car. So I've shown you it on the command line so you know the kind of the really nitty-gritty parts of how to use Git. So when you use a GUI, you know what's going on in the background. Okay, so we've made that change to my README online. But if I have a look at my README on my local machine, still README is spelt a bit wrong. So I've heard that someone's made a change online. So if I do a git pull, this is where the internet connection dies. There we go. So it's gone ahead and it's pulled in changes to my README file. So if I go take a look at my README file now, there we go. I pulled in the changes from the remote repository. So it's not all just about me. Someone else could have made that change and pushed to the repository, and I could have pulled that change back from them. This is one of the core fundamental features of revision control, like Git, is that it's really easy to work in a team. You can all make changes across the globe if you really want to. You can all make as many changes as you like, and when you bring it all together, you can get their changes really easily on a local machine just by typing git pull. Back in the old days, you probably would have had to post them the file or something. I don't know how it was done back then. All on tapes and holes and pieces of paper and stuff. But okay, so enough about my computer. We'll go back to my presentation because this is the last slide, and I guarantee you this is the last slide. You can all go home after this. You're all free to leave. Git ignore. So you saw me compile a Java file. Well, I failed to compile a Java file. What happens if I actually compiled it? Who here doesn't know Java at all? All right. How old are you? You must have. Alright, so when you compile a Java file, what it does is it creates a compiled binary, if binary is the right word, that is specific to your local machine. It's specific to your architecture. For my purposes of lying, it's specific for our architecture. Okay, so it might not be, but for this case, it is for a lot of compiled code. Now that compiled code can be generated from your other code, so it's completely pointless storing it to start with because it can be generated at any time, and it's really annoying if you start storing in the Git repository because someone else will check it out, it will interfere with their stuff, and their compiled version, it might not be the right architecture anymore. So not only have you put something in the repository that's completely pointless, but you've messed over other people's work in the repository. So you want to ignore these things. You want to ignore certain files. You want to ignore these compiled things, these things that really aren't necessary. So you can use a git ignore file. I'll let you Google it and have a look at the syntax of it, but I'm just telling you it's out there because there's a lot of files we don't care about. And if you put in a git ignore file, you say, okay, ignore everything with a .class extension. That's what Java creates. It creates a .class file. If you say ignore everything with a class extension, Git won't even tell you it's in the folder. When you do git status, it'll go, oh, what are you talking about? I don't know what a class file is. I've been told to ignore it, and I'm going to ignore it. You can force it if you want. You can tell Git, oh, look, add it. I want you to add it. And Git will go, all right, fine. I've been told to ignore it, but you're the boss. But most of the time, we'll ignore it. It won't even tell you it's there. And that makes working with stuff that needs to be compiled really easy. Same for sort of like Eclipse project files. You give someone else an Eclipse project file, it's like giving them, I don't know, a cold or something. It's really annoying. So you make sure you don't commit those to the repository. Now, again, I've been talking the entire time today. We created our repository from scratch. We did a git init. We created it from scratch. We uploaded it to GitHub. But what happens if you're working with someone else's code? That happens quite a lot. So you're working in a team and they're like, hey Phil, just head over to GitHub, check out our code. Well, how do I get their code? You use a git clone. Git clone will take a repository and it will drag the entire thing to your local machine. Copy everything onto your local machine. It will take that remote repo and create a local repo for you. Same way, when we pushed our initial repo to GitHub when they didn't have anything, we're pulling the entire one back. Was that a question or are you just stretching? It's just stretching. Don't stretch in such an upward direction. Keep them down. So yeah, git clone will take the entire remote repository, pull it onto your local machine, and then you can start working seamlessly, like nothing was wrong. It will look as if that repository has been there since your machine was, created, the dawn of time, because you'll have all those changes. Remember that one thing about Git is that you have everything on your local machine. You have no dependency on the remote one at all, unless, of course, you want to work in a team effectively. And if everything's gone wrong, I'm pretty sure this is the right command, if everything's gone wrong, if you mess everything up, if everything blows up in your face and Git hates you, you didn't get it the right Christmas present, it hates you so much, Git reset -- hard.
That's it.
Yeah, it will reset everything back to how it's meant to be.
No, to the last commit.
It's the last commit. It will blitz your working directory, it will blitz your staging area, and it will check everything out to the last commit. So everything will be Nirvana again. Nothing's broken, everything's fine. Let's pretend the last hour didn't happen. That
Unless
sort
you
of thing.
committed stuff.
And we've got a Git expert to point out that I'm wrong.
It's worth pointing out that it only will blitz files which Git is tracking.
Yes.
If you want to get your repository or your working directory into a version state, you can use git clean, and that will just wipe anything that it isn't tracking.
Yes.
But keep in mind that if you've explicitly got like settings files and things like that that are important to you, but is not being tracked by Git, it will blitz those as well.
It's important to note there are 157 Git functions. There are 157 command line functions, and I've told you about 8 today. Git's quite large, but you can use it really effectively with such a small set of commands, most of which I've told you today.
Some of them are also compound commands like
yeah.
pull, I think.
So Git pulls a compound command and puts two things together. But there's a lot of Git function out there. I haven't told you everything there is to know about Git. There's a lot of things, and I've been having a lot of arguments with people over the week of what I should include in these slides. But we've included the basic amount to get you up and running to be in a state where you can now use Git. You can all use Git. If all of you were following and you've been following me, you're now as much a Git expert as I am, to be honest. I probably know like 5 more things than you do. But there's all these other functions out there that I haven't told you about, but just Google them, they'll come really handy. Things like Git submodules, Git logs, not used that often. There's loads of other stuff. Go ahead, Google it, look up the documentation, because by no means have I even scratched the surface of what Git, like how fast and efficient Git can help you work. So that's pretty much me for today. I don't have any more slides, but I don't have a life, so I'll stand around and answer any questions you guys have.
Don't use GitHub for course log, obviously, because it's...
Yes.
Bitbucket is...
Bitbucket. I mentioned Bitbucket earlier on. They give you lots of private repositories. I use Bitbucket for all of my coursework. So I use GitHub for stuff that is essentially open source. Because if you start putting all of your courseworks on GitHub, very good point, you've got academic integrity to worry about, because people can just go on there, clone your repository, and boom, they've got your coursework, all of it, and they can see all of it up there. They don't even have to download it; they can just see it on GitHub. So one of the things I want to say is use Git for everything. I use Git for code, for documentation, for notes I want to take. If I could use Git for, I don't know, food I ate, I would. I would just use Git for everything. And I use Git for as much as I can, because there is nothing worse than going, oh, if only I had, there's no point in that. You might as well just use Git, because there's pretty much no overhead in it. So use Git for everything, all your documentation, but use Bitbucket for stuff you want to keep private. Use GitHub for stuff that you don't mind other people working on, for example. If you've got a neat command line tool you want to put out there, maybe, create the base of the code, stick it on GitHub, other people can fork it, do what they like with it. They can make changes to your one, but it's a very good point. If it should be private and you shouldn't be sharing it with other people, stick it on Bitbucket, and you can stick as many things on Bitbucket as you like. I have about 50 repositories on there now, all for free. As I said, I don't know how they make money, but yeah.
Also, there is a planned Forge replacement. Forge being a current SVN-based system that will be Git-based, probably with SVN as well, if people want it. That'll probably be a summer job, but it's not happening quickly.
Yeah. So I've told you about Git today, but SVN's the other big hitter that we've touched on several times. SVN's, its usage is slightly less complex as Git, I would say. It's kind of very much it's a centralized SCM, as I spoke about earlier on. So if you're using Forge, for example, which is the ECS one, you'll be pushing all your changes to Forge. That's your central repository. You don't have to worry about backing up. Those guys do it. But it's essentially, you have your code, you push it to Forge, you pull it from Forge. That's kind of the usage you're going to get from things like SVN, those sorts of centralized ones. There's a couple others out there, like Mercurial as well. Mercurial does things like file locking, getting thumbs down at the front here. The thing about SVN, Git, Mercurial, all those sort of things, it's like Marmite. You either love it or you hate it. I love Git, not in the I'm going to marry it kind of way, but I like it. You might not like it. It might not be to your taste. You might think, why do I have to do all that adding of files every 5 minutes? If you really don't like that, use SVN. I'm not here to tell you to use Git. I'm just trying to get you riled up about revision control and how awesome it can be and how much it can help you. Questions? Again, I'm looking for another question. Nick.
Just quickly, you know when you get pulled for the readme file for change?
Yep.
If you'd have fetched a merge, would it ask you which version you wanted to keep? Or did I misunderstand something?
If I'd made changes to my local, it would have warned me that I've made changes before I did a merge. It would say, you've made changes to your local one, your add pull sign overwrites it. It would try and do a merge, I believe. Otherwise, would it blanket tell me that I can't check it out? It wouldn't. It would try and merge it.
It would, if you had... I'm not sure without doing it, because I don't normally do it that way, because I'm special.
Yeah. If you've made changes on your local one, I would presume Git would try and merge together.
It will do one of two things. Either it will go, this isn't a fast forward commit, you're going to have to do some virtual handling, or it's going to go, well, I'm going to dump you out into a state where there are merge conflicts, or it will merge, and then it will have in the file like arrows in and arrows out. Like I think SVN does a similar thing.
We can try it out. If I can try and do it now. If you carry on explaining, and I'll quickly.
You gotta share your terminal.
Good idea. Right. Okay. So let's make another change to my README file. Edit this file. README from my project. Foo. Added meaningless word to README. It could be meaningful depending on which language you speak. Okay, so I've made a change to my README file, and then if I make a change to my local one, I'll go to the end of the line. Dollar, there we go. Bar. Okay.
Don't commit.
Not going to commit.
Pull. Just try pulling now.
Okay, so what we're doing here, guys, we're getting into a bit more complex things here. So I've made a change to my local one, and I've made a change to the remote one. So this sort of thing would happen, say, I'm working with another member of my team, and he's gone, actually, I don't like the colour of something, let's change the colour of it. And I've gone, I like the colour the other way. It can work with any sort of code. So if we've changed the same thing. So if I do a git pull, Git will do one of two things, and we have to stand back and wait for it.
This one, it will complain at you because you have existing changes.
Yeah.
So in this case, you could have local changes when you're doing a pull, and it will just overwrite the file. So long as the pull doesn't affect your local changes. But in this case, because it does, it will just go, I'm not going to do anything. I don't know how to handle this setup. So if you commit README now,
Right.
you can't commit with a blank message. It will
As I was saying earlier on, guys, that's a bad commit message. But because we're fiddling around here, it's not that bad. So now if I do a git pull again.
Yeah.
Okay, so we've created a conflict. Now, when you're working in teams, if anyone here's used SVN, they know that conflicts are basically like getting shot in the kneecaps. Whenever you get a conflict, SVN will throw the biggest wobbly you can imagine it will throw every single toy it has out of the pram, and it will create 100 different files in your local. No, not 100, but it will create different files of different versions of things and say, right, okay, I've got a conflict. You have to sort this out. So you have to go manually through the files and figure out what the change is, and then sort out SVN. Whereas Git will do the following. It will take your file and it will say, okay, so this is one and this is the other. This is the one I got from your local repository at the top there. That's the one I just put in. And it will say, this is the one I got from the other version that I found. The version that someone else changed. So in this way, Git's conflict handling is actually much nicer than SVN's, because with SVN you end up with 3 different files. You have to, the original, the one you had, and the conflicted one, and then the result. Head in this term is where the end of my repository is, the most recent one in my repository, isn't it? My local repository, bear in mind. Whereas that massive hash at the end there is the commit. So commits in Git are identified by large hashes. It's the easiest way to ensure uniqueness. So you have a massive hash for a commit. So what that's saying is your local repository had that one, which is in, and then we've got the one from the remote repository, which is that one. Now it told me I need to sort this out, but it's put it in the same file for me, so it's pretty simple for me to do. I just go, which one do I want? It's the question. Right, so do I want bar or foo? Well, I'm a sheep enthusiast, not in that way, so I like bar. So I'll keep bar. Okay, so it's saying I've got a changed README file. Do I just need to do a commit now, I think, isn't it?
You have to add it.
I have to add it and commit it. So same things apply. Git README. So if I do a git status, actually. Branch, origin, master of diverge. 1 different commits, each respectively, nothing to commit. Merge branch master. I can put in a message if I really want, but it's telling. See, that's another reason why Git is really nice. It's very verbose and it does a lot of stuff for you. So I had a commit. I was like, oh god, I got to commit. It's the worst time of my day. This has ruined my entire afternoon. But don't worry, Git put it in the same file for me, made it really easy for me, told me what was going from one end to the other, put nice little marks around the whole thing, and said these are the things you got to change. Not only did it do that, it automatically filled out my commit message and said, look, you're fixing a conflict here. So my bad day just didn't get worse like it would with SVN, which would just keep kicking me in the groin until it's finished. So I can just leave the commit message like that. It says I've made a commit, and I can leave it at that, or I can push it to the remote. And then, that's some text edit file. So we had foo there. So I fixed the commit, and now it's bar. And we had a conflict. We solved the conflict. That's probably one of the hardest things you'll have to deal with revision control as a whole, is fixing conflicts. And a revision control system that can deal with it as nicely as Git can, in my mind, makes my life a lot easier. I've used SVN, and people that I've worked with in SVN projects know that it's a little bit of a headache sometimes. Using SVN by yourself, perfect, I love it. But when it comes up against a commit, I hate it. But that's my personal opinion. SVN has its credit, Git has its credit. I'm not saying use one or the other, but some of them are nicer for some things. Right, next question. If we have any more questions, or you're bored and want to go home, or lynch me, either one.
Oh, if you live in Portswood, apparently it's on fire, so you probably can't go home.
Oh, wow. What?
Okay, anyone that lives in Portswood, it's on fire, so we're having Git fun for the rest of the evening.
Who's committing insurance job?
Was that commit?
It's not my flat, it's my mom's still.
Did you say who's committing that insurance job? Was that a Git joke, or are we just going to... Git jokes aren't allowed when using Git. Okay, so we dealt with basically how you work by yourself, a bit of how you work by team. But go and have a look at, there's a lot of guides online on how to use Git. I've basically given you a whiz-through tutorial. Did anyone really find this useful? That's almost half the room. That'll do for me. Oh, most of the room, okay. Okay, right, well this is a talk on organised by DevECS. Thanks everyone for turning up. Thanks to my lovely assistant Nick at the front here, who got me out of a tight spot. Round of applause to Nick. We've got another talk next week on agile software development in small teams by an external company called Snowflake Software. They'll be coming in and I don't know what their presentation is going to be on or like, but it's going to be on agile.
It's going to be on like the agile process and tools which they use in a real world context. So you talk about agile and some tools, but not how they actually apply to a specific business. So come along to learn about how one company uses these tools to do their job.
Okay, well, thanks very much, guys. Have a good evening.